Mr. Moore's math class. Good afternoon. That's right, guys. Welcome to Mr. Moore's online math class. Once again, we've got plenty to get through today. We're learning all about sketching graphs containing stationary points. Alright, so like always, make sure you grab yourself a hot chocolate, grab yourself a pen and some paper, put your feet up on the couch, and let's get stuck straight into the lesson. Okay guys, as I said, today we're learning about how to sketch graphs containing stationary points. Now, no longer will you look at this kind of thing here as being a stationary point. All that's gone out the window. As of today's lesson, you now need to think of stationary points as being a turning point or a point of inflection. So let's have a look at stationary points in a little bit more detail.
In this worked example, we're going to use Alfred the ant to demonstrate stationary points. Note that for this section, Alfred is walking uphill, meaning the gradient is positive. Hurrah! Alfred reached the top of the hill, and at this exact point the hill is flat, meaning the gradient is 0. And because of this, Alfred has reached a local maximum turning point on the graph. Because Alfred is heading downhill now, the gradient is negative. At this point here, the gradient is 0 once again, making it a local minimum turning point. Alfred is now going uphill, meaning the gradient is positive once again. In this example, we're going to have a look at a stationary point of inflection. As you can see, Alfred is walking uphill to start off with. This means that the gradient is positive. For this point here, Alfred is on flat ground. And unfortunately for the poor little ant, he's already walked uphill and he can only see another big uphill section to come. Because the gradients before and after the stationary point are both positive, this makes this stationary point a point of inflection. So, Alfred does what any normal ant would, and he catches a bus.
Okay, now let's have a look at a worked example on how to sketch graphs containing stationary points.
Okay, so for this worked example, it says for the function f of x is equal to x cubed minus 3x minus 2, a, find the stationary points and determine their nature, b, find the coordinates of all intercepts, and c, sketch the graph of f of x showing all stationary points and intercepts. Now this is going to be quite a lengthy question, and we're not going to have enough room to do it all on the one page, so I'm just going to draw a little box down here, and this is where we're going to write any relevant information that we're going to need to be able to sketch the graph at the end of the question. Okay, so here's the working out for finding stationary points and determining their nature. Okay, so for the first section of this working out, we've just written out the function, and we know that for all stationary points, f dash of x is equal to 0. So we need to actually go through and differentiate this original function to find the gradient function, which is shown here, because x cubed differentiated is 3x squared, negative 3x becomes negative 3 when you differentiate. Now, I know that for the stationary points, f dash of x is equal to 0 because it's flat, has a flat gradient when it's at a turning point. So therefore, f dash of x became 0 here. Right, and I made it 0 is equal to 3x squared minus 3. I then factorised, taking out 3 as a common factor, which you can see here. And then I factorise x squared minus 1, which becomes x plus 1, x minus 1 in brackets. Right, now I need to solve for each bracket. So that was x plus 1 is equal to 0, or x minus 1 is equal to 0. And then I solve for x for each one. This got me the x coordinate x equals negative 1 and x coordinate x equals 1. What I still don't know is my y coordinate, which we're now going to go through and find. So I'll show you the working out for that. So what we need to do is substitute our x coordinates into the how high function, which is f of x. Okay, so I've now gone and substituted our x coordinates of the turning points, that is x equals negative 1 and x equals 1, into the how high function to find the y coordinates. So substituting x equals negative 1, first of all, you get f of negative 1 is equal to negative 1 cubed minus 3 times negative 1 minus 2. When you go through and simplify that, you end up getting the y coordinate of 0. Therefore, the x coordinate was equal to negative 1 and the y coordinate was 0. So that's our coordinate of the first turning point. The next turning point, we substitute x equals 1 because we found that's the x coordinate for the turning point there. So x equals 1, substitute in, simplify, and you end up getting an answer of negative 4. So the coordinate of this turning point is 1, negative 4. Now the second part of this question asks us to determine the nature of the turning points. So to do this, we need to draw out a table for each turning point with 3 columns and 3 rows. And we're going to put the x coordinate of the turning point in the middle, so that is negative 1 for the first one. And we're going to go one place to the right and one place to the left. So that is negative 2 and 0. Our second turning point is at 1, so we go 0 and 2. So what we need to do is we need to substitute each of these x values into the how steep rule, because this will tell us if the gradient is positive or negative. So f dash of negative 2 was equal to 3 times negative 2 squared, negative 2 squared being 4, times 3 is 12, minus 3 is 9, so therefore the gradient is positive. And we can show that with a graph going up, or a line going up. The next part says f dash of negative 1, so substituting negative 1, you get 3 times negative 1 squared being 3, minus 3 is 0, therefore it's flat, and it will look like that. And f dash of 0, so substituting in 0, 3 times 0 squared minus 3 gets you negative 3, therefore it's negative, and the gradient is going down. Therefore, Tp at x equals negative 1 is a local max. Let's do the same now for the other turning point. So substituting f of 0 again, we end up getting negative 3, so therefore it's negative, and therefore has a negative gradient, so it's going down. Substituting x equals 1 into the how steep function, and you get 0, so therefore it's flat, looks like that. And then substituting x equals 2 into the how steep function, you get 9, so it's positive, which means it's going up. So therefore, the turning point at x equals 1 is a local minimum. Okay, writing this key information into here, because we're going to need to know it to sketch the graph. Local maximum turning point at the point negative 1, 0. There is a local minimum turning point at the point 1, negative 4. Alright, so let's clear up this information now so we can make room for the next part. And the next question says find the coordinates of all intercepts. Alright, so this is just using the how high rule. So you've got f of x is equal to x cubed minus 3x minus 2. And I'll show you the working out now for all of the turning points. Alright, so finding the y-intercept first of all, we know the y-intercept happens at x equals 0, so substituting 0 into f of x, and you end up getting negative 2. So therefore, y-int at 0, negative 2, and we'll write that down into the important information box down here. So the y-intercept is at 0, negative 2. Okay, so to find the x-intercepts, we make y equal to 0. So I've got f of x is equal to x cubed minus 3x minus 2, making that equal to 0. Now because there's different types of x, there's x cubed and x's, etc., we need to factorize. So I need to find factors of f of x. Say for example, let's try x plus 1. So to do that I substitute negative 1, and then when I found out that my remainder was 0, I knew that x plus 1 was a factor, with a little smiley face. Alright, then I've got f of x is equal to x cubed minus 3x minus 2, just written out the function once again. I've now gone through and written out the coefficients. So the coefficients of f of x are 1, 0 for x squared, negative 3 for x, and negative 2 at the end. And of course, because I know x plus 1 is a factor, I've got negative 1 out the front. Okay, so you go 1 plus 0, have a little plus here, 1 plus 0 is equal to 1, 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1, negative 1 times negative 1 becomes 1. Negative 3 plus 1 is negative 2, negative 1 times negative 2 is 2. Negative 2 plus 2 is 0, and of course that is our remainder, and we know it's a factor, so therefore the remainder should always be 0. So then I end up getting x plus 1 out the front as a factor, and I've got this here, my constant is negative 2, which you can see here. My coefficient of the x is just negative 1, so negative x, and my x squared, the coefficient is 1, so it becomes x squared. So I get x squared minus x minus 2 in the second bracket. Factorising the second bracket now, the factors of negative 2 that add to negative 1 are negative 2 plus 1. Negative 2 plus 1 is negative 1, and yes, they are factors of negative 2. So this factorise ends up being x plus 1, x minus 2, and x plus 1 in brackets. Now note the x plus 1 has been repeated, so it actually becomes f of x is equal to x plus 1 squared, x minus 2 in brackets. Now, finding the x-intercepts, we need to make y equal to 0, or f of x equal to 0. So I've done that here in this line here, and I've gone through and solved for each bracket. So I've got x plus 1 is equal to 0, therefore x is equal to negative 1, and x minus 2 equals 0, therefore x is equal to 2. So the x-intercepts occur at the point negative 1, 0, which also happens to be a turning point because it's a squared value here, and of course at the point 2, 0. So let's go down and write that relevant information into our box down here. So therefore x-intercepts are at negative 1, 0, and 2, 0. Now finally the last question says sketch the graph of f of x showing all stationary points and intercepts. So alright, so let's go through and put in all of our points of interest. So let's go through first of all to the intercepts. So you've got y-intercept at 0, -2, which is here, x-intercepts at -1, 0, and 2, 0. Local maximum turning point at -1, 0, so if it's a local maximum, it's going to go up like that. And local minimum turning point at -1, 4. So it's going to come down like that. Okay, hopefully now you can start to see what the graph's going to look like. So let's just basically join the dots. And remember to go through and label each of the points, as can be seen here. And that there, of course, is called f of x. So from now on, when sketching graphs, you need to make sure that you find the turning points of them, the y-intercepts, and the x-intercepts, plot all your points, and then join the dots. Okay, so first of all, let's define the function. So we're going to go menu, actions, define, and we go f of x is equal to x cubed minus 3x minus 2. And it says done. Therefore, remember, whenever I type in f of x, I get my function there. Alright, so let's go through and find the turning points now. So to do that, we need to differentiate. So you go menu, calculus, derivative, d over dx for f bracket x, so for f of x, and we get that differentiated. Now I want to find out the turning point, so I make that equal to 0 and solve. So I can go menu, algebra, solve, and I can just go up here, press enter, equals 0, comma for x. So you get x equals -1 or x equals 1. To find the y coordinates, and I can just substitute those x equals -1 or x equals 1 into the f of x function. So I just go f of -1, and I get the coordinate -1, 0. I'll be writing this information down, of course, and then I could substitute in f of 1, and I get the y coordinate of -4. So I've got the coordinates -1, 0 for a turning point, and 1, -4. Okay, let's go through and find the y-intercept. So you would just do, for the y-intercept, you just make x equals 0. So you go f bracket 0, press enter, and you get -2. So the coordinate would be 0, -2. So to find the x-intercepts, you would go menu, algebra, solve, f of x equals 0, comma for x, press enter, and you get -1 or 2. So therefore the x-intercepts are at -1, 0, and 2, 0. You've now got all your points, all your intercepts, and all your turning points. You can go and plot them on the graph. Using a graphs page, what we do is we go home, go to the graphs page, press tab. Now we've already defined f of x, so we just type in f of x, and up it comes. Now we go menu, trace, graph trace, and we go along. So already you can see that the y-intercept is at 0, -2. Press enter for the y-intercept. Press 0, where it comes up with 0, press enter. You get the intercept at -2, 0. Go across to your other intercept. Happens to be maximum, but also a 0. And it's at -1, 0. And let's go down to find our minimum point, -1, -4. And that's how easy it is to do this on the calculator, sketching the graph, finding all of the intercepts and all of the turning points.